Okay. Good afternoon, everyone. I'm Jayashani Gunarathne, software quality assurance engineer from 99X Technology. So I welcome you all to this university series organized by the Automation Drive of 99X Technology. This is a series of 4 sessions. 2 sessions will be held today, and 2 more sessions will be held on 30th of June. The first session for today is on continuous testing, and it will be conducted by Aravinthan Ramraj, one of our DevOps guru, and he's the senior product lead in one of the challenging and evolving project in our company. So without further ado, let's get started. Over to you, Aravinthan. Thank you.
Hi, good afternoon. Thank you for those kind words. Good afternoon, everyone. I'm Aravinthan Ramraj, and what we'll be looking today is a very interesting topic called continuous testing, and it's I would say rather rather than saying interesting topic, it's also a topic that has been evolved a lot over the years as well. So it's going to be a very nice way to talk about it as well. Having said that, I will also say that continuous testing is a concept that has been evolved over automation testing, like what you have studied all these days with your coursework. Automation testing has been one of the paramount importance when it comes to testing, and with uh, with automation testing becoming more and more important these days, the continuous testing has become a more of an evolution on top of automation testing, and that kind of embraces the new way of working and like the DevOps and etc. Okay, let's get into this topic without further ado. First question is, why does it matter? Why is continuous testing this matter to us? So before to answer that, we should also ask what we did with automated software testing and why we did automated software testing. Now, automated software testing primarily was done to reduce cost and maintenance. And then by reducing the maintenance costs, we also will be able to have more time for ad hoc testing and exploratory testing, improve the test coverage of our regression suite, and save time. So ideally, an automated software testing was a way of saying that we have a evolving application or a product suite that we wanted to keep on maintaining. And when we add new features, we want to make sure that we don't break other areas. And for that, we do a lot of regression testing. Let's use automated softwares so that we can automate our tests, so that we can save a lot of time. Now, this works really very well for a traditional way of working, but the traditional way of working is going out of way, and the businesses are evolving. The way new technology is being built is evolving. New product is being evolved. So there is a continuous shift in this technology business landscape, where a lot of norms are being challenged and being changed. One of the one of the biggest eye opener for me as a software engineer myself back in the days is that sometime back when I started my career, the perfect software do exist. That means we could always strive to achieve a software which has zero bugs as much as possible, though it's very hard, and also a software that works very well for our customer needs. But in today's world, with so much of options available, there is nothing called a perfect software. So something that is perfect for me might not be perfect for you. So for me, for example, WhatsApp works best. But one of y'all who's listening, WhatsApp might not be the best way of communication. You may choose Snapchat or maybe Facebook Messenger app. So what works for me doesn't work for you. And the same goes for businesses as well. So as this concept of perfect software doesn't exist, has come into place, the what is the driving factor for coming up with new software or features is that the business is only looking at how fast we can come up with a new feature that differentiate us from others. Going back to the same example of WhatsApp and Messenger, we all know when the stories came in, right? I don't know which company came up with it first, but stories came into the whole scene, I think, with Snapchat. And all of a sudden, all of the other companies were just copying them and trying to come up with their own way of putting stories. And now, if you have an instant messaging app without stories, you might look down on them. And what this says is that in our current working environment, the way the business is evolving is not planning a lot ahead, but trying to see what new feature that we can bring in, a differentiating feature we can bring in as quickly as possible. So this too, conceptual mindset change in business is changing a lot in terms of how we develop software as well. So those change has drilled down into changing the way the application is architectured today. So back in the days, if you have a monolithic application and you have an on-premise server, that's absolutely working. But today, when you want to create a new application, if you're not in cloud, you're not the advanced technology company, because cloud is the way forward. And APIs are becoming a more pronounced way of communication between different applications and exposing some of the data you have. So with the microservices architecture, it creates a very complex array of tools that we as professionals have to create a new software product. And it creates an virtually endless combination of different ways of creating one thing. You might be familiar with mean stack, and today mean stack would be really good, but in 5 years time the mean stack could be replaced by something else, something more advanced, something like what Dino is doing with Angular. So uh, so this way of, we are in a very fortunate era of software development where we have so much of tools and protocols available with us. We can just become so interesting and creative in creating completely new way of approaching the same problem. That coupled with the requirement to deliver fast has led us into a lot of new discoveries into agile way of working, the Scrum, the Kanban, bringing in concepts like DevOps and continuous delivery and continuous integration. These are all things that you've been learning so far in your curriculum, and all of these are being slowly being adapted into real world, and now these are all become a mainstream things. And as such, the if you look at holistically, what has happened is that the way the business is run is changing. Because of that, the way we architecture our application is changing, the way we build our application is changing, the way we also deliver these applications is also changing. And all of these has created another big impact in all of this technology modernization, is that software has become the primary interface for business. Now, if you ask a question of what business Uber is in, you would say Uber is a ride-hailing company. But if you look at it, they don't have you own any cabs. If you're a ride-hailing company like Kangaroo or something, sometimes you might have to own certain cars. They are primarily a technology company, and they're just connecting people using technology. And if you take away that technology, Uber cannot exist at all. So what has become is that maybe 10, 15 years ago, that's not the case, because technology was used as a supplementary thing to enhance productivity. For example, a CRM application or a ERP application, which you would use to store all your internal data and help you manage your data effectively in an organization. That compared to an Uber application is completely different. So software is the primary interface for the business, and an application failure is a business failure. So if Uber cannot get you in a cab, or it continuously shows you error, Uber doesn't get any revenue anymore. But that's not the case where you have just a CRM application. If it fails, it fails. Doesn't mean your entire business is going down. Taking all of this into consideration and looking at testing as a holistic approach, we started to understand that the traditional testing does not work as it is. Because what we did with traditional testing is that we have an application developed by developers, and we deployed into some test environments, and where we as QA engineers go, we'll start testing. And while testing, we'll uncover bugs, and we go back to the developers, ask them to fix. And there is a chance that some of the bugs may get leaked into production, depending on our how good we are in QA. But there is always a chance. And we try to minimize all of these chances with automated test and etc. But by the time we do testing, most of the bugs have been already created in the code. So a traditional testing does not work as in a way to prevent creation of bugs, but only identifying what bugs we have. So that is where we wanted to understand how could we go from identifying bugs in software to preventing bugs from being created in the first place. And this thing, what we call broadly, is called the shift left testing concept, where we try to test at the source of the code. This coupled with this thinking is a manifestation of the continuous need to evaluate quality based on new landscape. Just to give you an insight on this aspect of it, is that how we did quality assurance 10 years ago is not how we are doing today. And how we are doing quality assurance today is not going to be the same way we are going to do in 10 years' time. That's the beauty of being a software engineer, because you tend to get exposed to completely new tool sets that will help you to approach the same problem in a completely new way. And the answer to this problem of where we wanted to couple our test and test automation, and at the same time we wanted to prevent bugs rather than identify bugs, is what led into this thought process of continuous testing. So continuous testing is a process of executing automated tests. Now that's important. It's execution of automated tests, but why is completely different. Uh, Executing automated tests as part of the software delivery pipeline in order to obtain feedback on the business risk associated with the software release as rapidly as possible. Now, let's just take a minute and try to understand what these four topics are. By the way, just stop me if you have any questions in the middle, or raise hands, etc.
Yeah, Aravinthan, can you share your screen, the PPTs?
Are you serious? It's not shared?
Yeah. As
Oh
we
my
are giving you
God.
the intro part, so I think it's
Is it? Oh God. Are you serious? Is it shared now? No.
uh, your screen is shared, but we can see your desktop only. We can. I think you'll have to select which screen you're gonna share.
Oh my God. Just so embarrassing. Is it shared now?
Um, now,
Uh,
now we can see.
yeah. Now we
Oh
can
my
see.
God.
Now we are.
Why didn't you guys stop me?
I thought in the beginning you are giving a bit lengthy introduction to the topic, so we were waiting and couldn't
Okay, okay. I'm
didn't
sorry.
want to disturb as well. So okay, fine.
Okay, no problem. I can recap. Just give me a second. I can
Okay.
recap that part. Yeah, no problem. So I'm really sorry, guys, for that mishap. But then again, as I was saying, trying to understand how automated test software test was working, like I touched upon, these are the four areas where we wanted to save time. We wanted to improve test coverage. We wanted to increase the ad hoc exploratory testing and reduce cost and maintenance. And as such, we were talking about how the business landscape is changed over the period of time, where the business doesn't want, they don't have a need for perfect software. What they want is they want to deliver new business differentiating software. This is where we discussed about how the new features like stories came in, and where other companies wanted to follow suit, and they wanted to deliver it as quickly as possible. They don't want to wait for a long time. At the same time, we also looked at how these differentiating softwares now means that if you don't have certain features in your messaging app, you don't consider that as a messaging app altogether. We also touched upon how when new business landscape is changing, the way we deliver application and the way we architecture application is changing as well. How the new advent of cloud computing and then the APIs, the microservices, these have enabled us with a lot of tools and ways for which we can combine a lot of different protocols and technologies to create valuable business solutions for a problem we have. So this is where we touched upon how lucky we are as a software engineer in this era, where there's new technologies coming up every other day, where we can be in a position to master certain technologies and come up with really intuitive solutions. And we also looked on how this whole new application architecture, just like the advancement in the application architecture, the advancement in the processors and delivery has improved as well. When we adopted Agile, and that led into DevOps and continuous delivery and continuous integration. Now, not only we have a very good tool set to build our application, we have a very advanced tool sets for us to deliver applications. All of these has led to a point where, as we saw in the Uber's case, where the software is the primary interface for business. It's not that a software is helping you to do something, but software is the business. The same can be said for Facebook, where if you don't have the Facebook, they don't have a business. Same can be said about Google. If Google doesn't have its search engine and YouTube or its advertisement engine, they don't have a business. So back in the days, we used to have machines, tools, and people as inputs who are running the business. Today, people are using computer as a way of running businesses. And taking all of this into consideration, we understand that traditional testing does not work as it is. The primary reason why we discuss that this doesn't work a lot is because in the traditional testing world, what we were looking at is to identify bugs in the code rather than trying to prevent. And this is where we spoke about how this shift left testing concept evolved and how automation testing is evolving into a more complex way of working that we will talk in a bit. So this pressing need to evaluate quality based on new business landscape is what has given birth to something like continuous testing. Just like it has given birth to DevOps and Agile, it has also given birth to this continuous testing. So let's take a moment to understand the definition of continuous testing. So continuous testing is the process of executing automated tests as part of software delivery pipeline in order to obtain feedback on the business risk associated with the software release as rapidly as possible. So let's try to pick up these four keywords in this definition, because this is the core of continuous testing. As I already introduced you to, continuous testing is an evolution of test automation. It's just much bigger, and the why part of doing automated tests is what has led to continuous testing. The most important thing about continuous testing is we wanted to obtain feedback on our delivery pipeline. So continuous testing gets plugged directly into your DevOps pipeline and cycle. And what we want to know is not how much of bugs we have, but what is the risk of the current software. So to put it into perspective, when we have a lot of bugs in our software, there is a lot of risk associated with it. Because when we have a critical bug in our software and we allow it to go to production, then there is a high risk that the users will actually hate the product or they will start complaining. So when you have a high number of bugs, it roughly translates to high number of risk as well. So from a business perspective, like if you are a product owner or someone who's looking at building this product, what you would like to do is assess the risk. And as a QA specialist and engineer, what we should be also striving to give is a risk assessment of the current software, rather than saying we have this many bugs in our software. And all of these should aid in us in delivering software as rapidly as possible. That means doing very fast release cycle. So if you boil down all of these two and look at it in a holistic perspective, what is continuous testing is trying to do is you give actionable feedback to the stakeholders at the right time. And the testing occurs across the software delivery pipeline. In the traditional test automation, what we used to do is we used to run our automation tests once everything is built and only once at that time. But here, what we're trying to do is we're looking at an entire delivery pipeline, like in a CI/CD pipeline, and see where we all can automate and what are the different things we can automate. So if you look at it from a general perspective, what has become is that this way of testing, continuous testing, has become a necessity in today's world rather than nice to have. Maybe 5-10 years ago, these are the things you would say it's a really nice, cool thing to do. But today, it has become a necessity, and the chances are high that when you finish your degrees and walk into a corporate environment, most of the organizations are doing some of the things that we are discussing today. So it's really nice for you all to get this perspective as you go through your curriculum as well. Okay, going a bit detailed into continuous testing, let's try to understand what is these traits of continuous testing. But before that, do you have any questions or any issues with my screen sharing so far? Hello. Hello.
We can see clearly.
Okay. Cool. If you have any questions, just drop your questions in the comment section so we can pick it up at the end as well. Okay. The next is the traits of continuous testing. Now, the first, as we said, is that the primary thing for a continuous testing is assessing the business risk. And the next trait of it is that that we usually don't see in a test automation is that we always have a stable test environment which we can provision on demand. So what has happened is that with the advent of cloud computing, we as a test engineers, we will be able to get a new test environment as and when we want by subscribing to some of the cloud services like on AWS or Azure. So the essence of this is that you create your own test environment where you want to run your automated test suites, and you delete your test environment once it is run. so that you don't incur costs. And with this infrastructure, it is very easy for us to seamlessly integrate all of our testing into software delivery pipeline and DevOps, like using Jenkins or Azure DevOps. There are so many other tools, so it will be very easy for us to seamlessly integrate this. And most important thing here is that how we give feedback. Now, usually in a test automation, what we used to give is a report on all of the bugs we have found, all of the areas we have seen flagged as broken when we run our regression suite. But in a continuous testing, we go an extra step. What we say is that, yes, we have certain number of bugs. We also say that what is the risk of having these bugs, and is it okay to have these bugs in the production? So this is where I said the initial slide where we said there is no perfect software. Today, a lot of organizations, a lot of companies have come into terms that you cannot eliminate all the bugs. You have to live with certain number of bugs. So our primary goal is not to identify and fix all the bugs, but identify the bugs and understand what is the risk of having these bugs. If certain minor bugs are okay to have, then we always go ahead and say it's okay, we'll promote this code to production. So as a QA engineer, our primary job is to do that. And then finally, we should be able to give a safety net where the team feels that they're protected with a lot of quality gates available, so the user experience is intact. Having understood some of the traits of continuous testing, let's dive a little bit deep and in specific understand the difference between test automation and continuous testing. Now, I have to warn you, this is not an elaborate list of all the differences you could find of a test automation and continuous testing, but I just picked up most important ones, which makes a huge case for continuous testing. First is risk. As I've been talking all this while, continuous testing is all about identifying risks. So it's not about identifying how many bugs we have. It's about identifying is the release candidate, or what we say is that whatever things that we have built so far, is it too risky to release or okay to release? That is what we're trying to figure out. We're not trying to figure out do we have 50 bugs or 100 bugs or 0 bugs. The reason why this thinking is important is that how we define our test automation completely differs from the thinking of only identifying bugs, but also to identify risk. Once we have this mindset change, the way we look at tests is to create tests that bring out the risk rather than figuring out what is the bugs itself. So how do we approach that? That's what I put on the right hand side, is that instead of looking at the user functionality and saying that we are going to test everything and automate everything, we like to understand what are the major flows and what are the risks associated with that major flows if failed. And we will map all the risks across the application, and then we create a risk matrix. We say is that these are the areas, if fail, will have a high impact to our software. For example, going back to the Uber's case, the highest risk in Uber is that a user cannot find a new cab, where their search functionality fails. But that functionality compared to the functionality of sending invoices in email is not of high risk, because even if that fails, they could manually send that PDF in email to us. So if you were an engineer in Uber, what you would do is you would flag search as the highest risk component and PDF as a low risk component, and you would focus on making sure that high risk component, the search, being automated and test every release, and the PDF not so often. So that is the step 3, where you create a test suite that achieves the highest possible risk coverage. In the test automation, what we do is we try to achieve the highest test coverage. But in continuous testing, what we try to achieve is highest risk coverage. And then when we finalize our test, our report should expose this risk exposure to all the stakeholders. So everyone should understand what is the risk involved with the current release, what's the latest features we have built. So that is risk component. Second component is breadth. So what is breadth? In a typical test automation, we usually get involved with test automation at testing the UI, that is the GUI test automation. There is a lot of trend in automating APIs now. That is also what test engineer does. But usually, quality assurance engineer kind of scopes all of the automation and testing work within those two arena, the API as well as GUI. But in an honest way of looking at an application is built by multiple layers: the back end, the front end, and the data access layers. Then you have the business layer where you have the business functionality. When you only test the UI, you only test the surface of the application, or I would call testing the tip of the iceberg. The breadth means in a continuous testing framework, what you look at is you tend to test the entire iceberg. So you identify the risk of different functionality, and then you go and test the entire stack of that functionality. Going back to this example of Uber's case, where we identified search as one of the important component or the risky component, as a UI tester, I would go and automate the UI search component. But at the same time, I would also go and look at what kind of unit tests has been written for that search UI component, and what are the API level tests has been written, and what are the integration tests has been written. And I would try to automate all of these tests and integrate them into one testing framework or component instead of working just on the UI. And that is what we are talking in terms of breadth. That is a primary differentiator when it comes to test automation. So one may ask, usually only the software engineer would write unit tests and the QA person would write the automated test for UI. Continuous testing doesn't say that this person has to do this or that. What it says is that as a holistic way, all of these breadth has to be tested, and we can still have the software engineer test the unit test and the automation engineer test the GUI, but they need to collaborate and understand the entire breadth that's being tested. So as the application changes, when the search UI changes, the UI testing gets updated, and we continue to update the entire stack or the breadth of automation tests. So how do we approach this in a practical way? Is that first we look at an end-to-end test. So we look at an end-to-end test that exercises the application from a user's perspective. So as a user, I open the Uber app and I select where I want to go, and I select a cab and place an order. Once that is done, we understand what are the different layers that is impacted by this particular user journey. And we have the front end layer, the UI, and the mobile application. Then you have the APIs communicating the backend, and the backend has a lot of algorithms working for the search component. And all of these are the important part that is integrated together to serve the purpose. And we tend to simulate testing across all of this. And how do we do that? We obviously cannot do that in production environment. We simulate virtualization, what we call as stubs. If you have learned in some of your modules, where we create a virtual environment where we can simulate all of this without impacting the production, and we test all of this, and we use that environment as we have already seen, which can be created on demand in cloud environment. So as and when we wanted to run a repeated test, they can subscribe for a cloud instance, and we can run that and then desubscribe from the cloud instance. And on top of that, it is also important that we do exploratory testing, because there is so much of a limit what we can do for automated tests in terms of continuous testing. Things like usability issues are very hard to simulate in an automation environment. So it's very important that we go and do such exploratory tests beyond the continuous testing. And we also integrate that as part of the final report, the risk coverage we respond. So that is breadth. So in essence, in a test automation environment, what we use to test is just the GUI or the API, and without looking into what are the other areas or other layers in the application, and have no integration or knowledge about what is being tested. In a continuous testing environment, all of these engineers collaborate together, and they create an entire automation framework where they could run the unit test, integration test, API test, GUI test in conjunction to evaluate the overall quality, and in essence identify the risk associated with that service. Finally, the time. Now, why it is more important is in today's world is that, like we discussed, it's a very fast-paced world. Now, I'll take another example. Again, going with Uber, if you had taken an Uber and you got dropped, and you see that you've been charged 3 times on your credit card. If you attach your credit card, or if you're paying through cash, initially it shows 100 rupees for a quick travel, but now it shows us 300, and the driver is demanding 300. You very well know it's a bug in Uber side, and you launch a complaint with Uber, and Uber acknowledges it. And most probably, you would like the Uber engineers to, the support team, to give you back this 200 instantaneously, or maybe within next 1 hour. I don't think so any one of us will be willing to wait 30 days or 60 days to get our 200 rupees refund. And that is the fast-paced world we are living in, where our customers are demanding a very high-paced feature delivery and resolution to problems. And that is the case. So that means our testing has to be really fast as well. That means our delivery has to be fast, and the testing inherently becomes fast as well. So in today's world, softwares can be released on a hourly basis or in minute basis. And there are companies like Google who deploy every minute, and Amazon as well. So you inherently will have DevOps, CI, and CD. When you have so much of fast speed, that means your testing has to be extremely fast. In my experience, if you take an average application with more than 10 screens, you might end up with a regression test suite with almost around 500 to 1,000 test cases. And the reason being is that there is so much functionality. And even if I automate that and run one by one, it would take at least another 3 or 4 hours, or maybe even a day for me to finish all of the automated tests. Can our users wait 1 day before which their problems resolved? In today's world, it's very hard. So that is why it's important we figure out what tests to be run and then how fast. How do you approach this in a practical sense? First thing is, as we have already discussed, we have to identify the test cases that we feel are contributing to the highest risk exposure or the search. So in Uber's case, I would prioritize running the search test cases rather than the PDF email test cases. And then all the test cases that we want to evolve over a period of time, we define this in a risk matrix. And then we go back to this test pyramid where we say that out of 100% of the test cases, 40 to 50% is run by the unit test, then 20 to 30 is run by API, and last 10-15% run by GUI. And we categorize all of our tests into that test pyramid. The reason being is unit tests are much, much faster than the GUI. By running 1,000 test cases only on GUI, we might not be able to do this fast enough. And then after identifying the task associated with the risk, identifying all the layers and categorizing them based on the test pyramid, we integrate this into delivery pipeline where we could run on virtual machines, like either virtual machines or cloud computers in a parallel manner. Now you would say in a test automation also we used to run in cloud, or we could use run in multiple devices or multiple browsers. Yes, true. But what we have not tapped into is that in a test system automation is that we strictly test the GUI. We strictly test only the GUI components. But if we go and start also integrating unit tests and using unit tests for its advantage, we might be able to do testing much, much faster. So there you go. Three important characteristical differentiation between test automation and continuous testing. One is risk. We are not trying to identify the number of bugs, but we are trying to understand how much is the risk involved with the new software. Second is the amount of breadth of testing. That is where we discuss not only testing GUI, we also test unit tests and the integration tests. And we use this for our time advantage. We want to do it as fast, so we include more of unit tests and API tests and less of GUI tests. We use cloud computing and we use virtualization and maybe testing in multiple browsers as well. And these are the primary differentiation. In essence, if you want to take away one thing out of this whole session, is that the understanding is that continuous testing is much, much broader scope than test automation. Continuous testing is achieved through test automation, but that's not the only thing. There are so many other aspects to continuous testing. By approaching our quality assurance through continuous testing mindset, we achieve far, far better quality standards. And that is what we ultimately want. With that, I thought I would also leave you with this final few slides, which I found very interesting when to talk about continuous testing is that what is in today's world a full stack tester is required to do. So as a professional, the quality engineer's work has been changing over the years, and I found this much more useful and much more relevant in today's world, how a new world of full stack testers are evolving and what it means. As a full stack tester, one must be able to define quality strategy and plan how we are going to do testing and how are we going to achieve a given objective and how are we going to maintain the quality standard and creating an overall plan for the entire testing. And the next is most testers shy away from code. And I think this is where the biggest change is coming in, where as testers, we will be able to work with code. We will integrate things, static analysis, code analysis like SonarQube and different things, and give a lot of feedback to developers giving on the code quality. And the next is giving effective incident reports. This is where we spoke about not only giving out reports on number of bugs, but also giving a report on what is the risk associated with it and how as a team of developers and engineers we can mitigate all of these issues and how we can deliver high quality software. So in today's world, telling that there is a bug is not enough. We should go beyond that and start communicating and mastering our communication, where we talk about how we can resolve them and also expose how we know about the risk exposure. Then we should be really good at doing automated tests, not only normal functional testing, but automated performance tests and security tests. Now, as young graduates, it might be very hard for you all to go and master everything. But what I would suggest is that start from one place and over the years, start adding all of these skills into your armory of skill sets. And as and when you grow in your career, you might be going from functional tests, functional automated tests, and then you might go into performance and then automatic performances and etc. So it gives a good wide range of skill set you bring into a new team. With that, you should be able to behave and act like a software engineer, where you know the JIT workflow, you know how to merge codes, manage code repositories, and etc. Which I don't think so is new to you. And you should be able to be good at CI environments. You should know how application is being built, deployed, because this is very important for you as you go and integrate your automated tests, regardless whether it's functional tests or performance tests. So you should be able to go and do it. And finally, the most important thing is thinking like a business owner. So what is thinking like business owner means is that you're not looking at the application and testing it from an engineer's perspective, but from a user's perspective. How this application could behave better and add value to the users. And using all of this knowledge about the application and users, you go and help the developers build a better product. So there you go. Those are the very simple things that I found as emerging trends in a full stack testing. And I hope this session was useful to you, maybe educational as well. Thank you very much for listening to me. Any questions?
Do you guys have any questions? You can maybe even type in the chat if you have any questions. We'll have like, we can take another like 5 minutes or maybe. Okay, so I'm assuming there are no questions. So thank you so much, Aravinthan, for that nice, splendid session. I hope you all enjoyed it and hope you learned something new today. And thank you so much, Aravinthan. Let's move on to the next session.